So far, we've learned one uniform motion formula, which is equal to V equals d over t. You can only use that in scenarios with uniform motion. That means the speed's not changing. And we've learned one formula when we have acceleration. That formula is A is equal to Vf minus Vi divided by t. What we can do with this formula is we can come up with 4 more formulas. So I'm going to show you how to do this once. You don't have to repeat it. I just want to show you where does the new formulas come from. So first thing I'm going to do is I'm just going to bring this t up here. So if I multiply both sides by t cancels out. I'm left with AT is equal to Vf minus Vi. Now I have this graph over here. So in this graph, I have t on the bottom. I start at some point. So I'm starting at an initial velocity, Vi, and I have a final velocity, Vf. So what I want to do is I want to find the displacement of this graph. And we learned when you have a velocity time graph, the displacement's found by finding the area. So when I have this line, I drop it down. That's a trapezoid. Can't remember the formula for a trapezoid. So what I'm going to do is I'm going to make 2 areas up. I have area 1, which is a rectangle, and I have area 2, which is a triangle. So my displacement is equal to my area, which is equal to my first area plus my second area. My first area is simply length times width. It's a rectangle, length times width, plus my second area is a triangle, which I know is 1/2 base times height. Well, let's look at this length and width. Well, the length is simply this over here. It's just t. Okay, the width is up to Vi here. So I know that my Vi times my t is just that, Vi t. In my triangle, I have 1/2. The base is simply t. The height is only this piece here. So from the bottom all the way to the top is Vf, but I want to subtract this Vi part. So this part here is simply Vf minus Vi. So Vf minus Vi. Let's keep going. I have Vi t plus, now Vf minus Vi, I look up here, that's the same thing as saying AT. So wherever I have that bracket, I'm going to put in AT. All right, let's expand. So 1/2 stays. T times A is AT squared. So AT squared. So T times T gives me my T squared. And this is my first physics formula for displacement. I have D is equal to VIT plus 1/2 AT squared. Now, I would never expect that you would have to do all that work to get to the formula. I just wanted to show you where it comes from. But what you do need to know is what that formula is. You do need to know that formula. Now, we can do similar things to create a few more formulas, but I'm not going to expect that of you. I'm just going to give you the rest of the formulas. So the first one is this one. D is equal to VIT plus 1/2 T squared. You already knew this one. We'll call that one number 2, which is A is equal to Vf minus Vi divided by delta T. There's another one. We'll call it 3, and that is D is equal to Vi plus Vf times T divided by 2. That's my third formula. Switch some colors here. A fourth formula is simply this one. D is equal to Vf T minus 1/2 AT squared. So this one's very similar to that one, except it's a Vf and it's a minus. And the last one, if I find another color, is this one, number 5, is Vf squared is equal to Vi squared plus 2AD is our last formula. Again, you don't have to do all this work, you just need to know the 5 formulas.